I can basically look at it as we go along. Are we still good in terms of seeing my screen? Just checking. I don't know, but I can ping you when 6.6 ends. Okay, so 6.6. 6.6 is all about hormones, homeostasis, and reproduction. So there's like 3 parts of it. Homeostasis is part of how hormones regulate stuff, and reproduction, mostly in this case, is knowing for SL at least, is knowing the different parts of the female and male reproductive systems, and then also knowing the entire menstrual cycle. That's basically all there is in the SL part of 6.6. So the first thing we start with is blood glucose regulation. So the hormone that we're going to be discussing in this is insulin. So blood glucose concentration within our blood is usually kept around 4 to 8 millimoles per decimeter cube of blood. And so this is a very tight window, obviously, since it's 4 to 8 millimoles. So to be able to maintain it in this, just this range, there's cells in our pancreas, which is a gland and an organ that basically assists in a lot of hormone secretion, but in this case, we only need to know about insulin. So cells in our pancreas monitor the concentration of our blood glucose, and they will secrete the hormone insulin or glucagon when the level of blood glucose is high or low. So when we have high blood glucose levels, so maybe like right after we eat something, when we have high blood glucose level, insulin is secreted by beta cells, beta pancreatic cells. So these cells stimulate liver and muscle cells to absorb glucose and convert it to glycogen. Glycogen is a complex carbohydrate, basically a complex carbohydrate, and that's one of the storage solutions for our body for glucose. And so granules of glycogen are stored in liver and muscle cells, but insulin also stimulates other cells, not just liver and muscle cells, to absorb glucose and use it in cell respiration instead of using fat. So we know that cell respiration uses either glucose or fat usually. So instead of fat, our insulin will basically trigger the cells to absorb glucose instead of fat. So both of these processes together will lower the overall blood glucose level. So for example, if you've just eaten something and your blood glucose concentration goes to like 10 millimoles per decimeter cube, these processes will bring it back down to the range of 4 to 8. And then there's responses to low blood glucose levels. So if you haven't eaten for a long time, your blood glucose will probably go down lesser than 4. So when it goes down to lesser than 4, your alpha pancreatic cells, your pancreas secretes glucagon from the alpha cells to stimulate liver cells to break down the glycogen that they stored into glucose and then release the glucose to be used. So this will raise the overall blood glucose level. The next is the condition that we need to know related to the homeostasis of blood glucose is diabetes. So there's diabetes, the actual term is diabetes mellitus, and there's 2 types of this condition. There's type 1 and there's type 2. The type 1 diabetes usually occurs begins during childhood. So it's usually genetically caused. The immune system will destroy our beta cells. So we know that beta cells are the ones that secrete insulin. So the immune system fights itself. So it's an autoimmune disorder where the immune system will destroy the beta cells in our pancreas, which means that there's not going to be enough insulin within our body. And then blood glucose levels will always be way too high because there's no way to convert the glucose into glycogen. So when someone has type 1 diabetes, blood glucose levels have to be measured regularly, and insulin injections, often before you eat something, are used to control the glucose levels. So insulin injections will just be basically a shot of insulin that works in the same way a normal body would, but since your own body can't produce the insulin, you have to inject it from like external sources. Diet by itself cannot control this type of diabetes, because high high blood sugars can occur even if you're not eating high sugar content foods, because there's just no insulin at all, and it's not like there's an insensitivity to insulin, which is what type 2 diabetes is. Type 2 diabetes is usually onset after childhood, so it can be acquired based on habits. And so target cells become insensitive to insulin, which means the liver and the muscle cells will become insensitive to insulin, and they won't they won't convert the glucose into glycogen. So insulin injections are not really an effective treatment. So the difference between type 1 and type 2 diabetes is, in type 1 there's just not enough insulin, but in type 2, no matter how much insulin there is, your cells themselves just don't want to recept the command to convert it into glycogen. So in type 2 diabetes, it's usually low carbohydrate diets that can control the condition within the body. And there's diabetes can vary in terms of stages. Type 2 diabetes can vary in terms of stages. If it's early onset, then there's ways to manage it really well. But there can be an increased rate of diabetes, which can be caused by diets rich in fat and low in fiber. So obviously there'll be, and then there's obesity due to overeating and lack of exercise. And then the third one is genetic factors that affect fat metabolism. So if your parents or grandparents have type 2 diabetes, there's the risk factor of the child having diabetes. Okay, before I go into thyroxine, I don't think there's any questions. If you want to note down stuff here, you can feel free to. I don't think anyone minds. I think we'll be okay with it. But as long as you don't bury if there are any questions. So, yeah. How much did you miss? Not a lot. You just missed blood glucose regulation and diabetes. Okay. Yeah, basically. Okay, so thyroxine. So thyroxine or thyroxine, depending on how you read it. In our IB textbook, I think it just says thyroxine without the E. The hormone thyroxine is secreted by our thyroid gland, which is present in our neck, or in our neck. Its chemical structure is unusual, since the thyroxine molecule has 4 atoms of iodine. Since it has 4 atoms of iodine, if you go a long time without iodine in your diet, then it prevents the synthesis of thyroxine and then causes something known as hypothyroidism. So this hormone is also unusual, as almost all cells in the body are targets. So thyroxine regulates the metabolic rate and also helps to control body temperature within our body. And thyroxine is implicated in heat generation, so body temperature, by shivering and by uncoupled cell respiration in brown adipose tissue. There's no specific information on what this is, but you just need to know that that's something that it causes or implicates. So in a person with normal physiology, cooling around someone would trigger increased thyroxine secretion by the thyroid gland, which will stimulate heat production. And thyroxine also causes the constriction of vessels that carry blood, or vasoconstriction, from the core to the skin, reducing the heat loss. So when you're at normal body temperature, and if you're at a normal body temperature and around you there's a high raise temperature around in the surroundings, and your hypothalamus in your brain will detect this raised temperature around you. Your thyroid gland will secrete less thyroxine, which means that there will be a reduced overall metabolic rate. There will be vasodilation, which means that more heat can be dispersed. And then there's reduced respiration in brown adipose tissue. But on the other hand, and then all of these processes will basically lower the body temperature back down to a normal body temperature. And then on the other hand, if there's cooling around you, then your hypothalamus, detecting the reduced body temperature, will signal the thyroid to secrete more thyroxine, and then that will cause an increased metabolic rate, vasoconstriction of skin arterioles, and shivering or increased respiration in brown adipose tissue. And this will again lead back to normal body temperature. Okay, the next is leptin. Now, this is related to obesity, and there is not an experiment, but an explanation related to rats and the genetic makeup. I'm not going through all of it, but I'm going through what leptin does as a whole. So, leptin is a protein hormone secreted by adipose cells or fat storage cells within your body. So if the amount of adipose tissue within your body increases, the concentration of leptin in the blood will rise. Leptin is the hormone that controls the appetite that a human has, and this is because leptin will bind to receptors within the hypothalamus of the brain that cause long-term appetite inhibition and reduced food intake. So leptin will basically make you less hungry, and you'll have less desire to eat, and then that will therefore control fat cells within your body, and this is what basically prevents obesity. So in rats, the leptin gene mutation is what usually causes obesity, but in humans, the leptin gene mutation is true in only a very small proportion of cases. And trials in these obese people have shown significant weight loss when the leptin injections are being given. However, leptin is a short-lived protein and has to be injected several times a day, so most patients with obesity and confirmed leptin gene mutations will refuse, since you have to inject yourself multiple times a day. Okay, thyroxine increases metabolic rate. Thyroxine increases metabolic rate, yes, and that's all you need to know. How much thyroxine is secreted will regulate the metabolic rate. Okay, the last one I believe we need to know, other than the ones related to the reproductive system, is melatonin and jet lag. So melatonin is a hormone that regulates sleep patterns and regulates basically, and your circadian rhythm. So ganglion cells within your retina in your eye will detect whether it's light or dark around you and send impulses to the suprachiasmatic nuclei, or the SCN, in the hypothalamus. And then the neurons in the SCN will control the secretion of melatonin by the pineal gland. Now, the pineal gland is close to the hypothalamus. Melatonin secretion will increase in the evening and drop to a low level at dawn. And this is because the darker it is, the more melatonin is produced, and the lighter it is, the less melatonin is secreted. In terms of jet lag, the body's circadian rhythms are disrupted by traveling rapidly between time zones. So this is known as jet lag, and the symptoms are sleep disturbance, fatigue, headaches, and irritability. And these symptoms are caused by the suprachiasmatic nuclei and pineal gland, which continue to set a circadian rhythm which suits the timing of day and night in the place where you were originally, where you traveled from, rather than setting a circadian rhythm for the new place. So basically, if you think about it, if you're traveling from, let's say, uh, uh Singapore to the US, your timing for morning and night is very pretty much almost 12 hours different. So your circadian rhythm will be set according to Singapore and not according to the US if you're traveling from Singapore to the US. The This will only last for a few days, when during which time your suprachiasmatic nuclei and your pineal gland will get used to the new regime, because your ganglion cells will basically recept the lightness or darkness around you and then therefore adjust the circadian rhythm accordingly. What else do we need to know about the pineal gland? Let me just. I don't think there's anything else. I think it does secrete something else, but I don't remember if there's anything else we need to know. Pineal gland IV. I'm just checking. Yeah, I don't know if you need to know anything according to unit 6. I don't see anything. It's just for us, we just know about melatonin and jet lag. Okay, time for an activity. You can kind of. Okay, hold on. You can kind of ignore the multiples of A, B, and C and D. I just put those there because I found two pictures of the same thing, because this is the front picture and then this is a sideways view. So if you can name A1, because that's part of the tube, A1, B, C, C1, D, E, and F. Yeah. And spoiler your answers, so put a double bar on each side of your message. There's also F. And there's A1 and C1 also if you choose to answer it. So for you, A and A1, if you swap the two, that's the right answer. Oh my god, you're here. I didn't even see. Hi. Here's a... Yes, 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 yes. No, the left and the right is both female. It's just the way it's, because the left is the sideways view and the right is the front. I don't think they have. This is just something, because okay, basically the left picture is from the Oxford textbook, I think, and then the right picture is from BioNinja. So I don't know if the because I didn't see A1 in the Oxford picture, so I just put it there just because. What is C1? We'll come to it. It's okay. No, you're not. You're not dumb. Okay, I'll wait for a few more minutes because there's several people typing, and then we can keep going. I'm not checking everyone's answers. You can do that yourself and then let me know how much you got out of 1, 2, 3, 4, 5. I'm just gonna say out of 6 because A1 and C1 are fine. We won't have to know how to do it sideways. I mean, you never know. It's rare. It's very rare, but you could possibly, which is why I put it there, just in case. Okay, I'm gonna wait. Is there anyone else? Okay, cool. Everyone, check your answers on your own and then let me know what you got out of 6. Just ignore A1 and C1. They're just, I mean, they're there just so you know that they exist. Okay, so A is ovary, obviously. Ovary over here, ovary over here. The ovary produces eggs, estrogen, and progesterone in the female body. And then A1 is fimbriae. So from what I understand, fimbriae just assist in grasping the egg once it's been released from the ovary. But if I'm wrong, feel free to correct me. B is the oviduct or the fallopian tube. It's been called both, but I think now we gravitate more towards calling it the oviduct. But again, you can call it whatever name, and I think it'll still be considered correct. So the oviduct will collect the egg over here, carrying it through to the uterus, and it's also the safe site where fertilization occurs. C is the uterus. So this is the uterus here, and this entire structure is the uterus here. So basically the uterus will provide protection, food, oxygen, and the removal of waste for the fetus during pregnancy. So this is where the embryo will implant after it's been fertilized over here. It'll make its way down and then implant here. C1 is just the endometrium. The endometrium is the thick lining of the uterus that make it a safe place for the baby to exist, the embryo to exist. D is the cervix. So the cervix is the thing that protects the fetus during pregnancy, and then also the one that dilates to this is the cervix, and then the same thing that dilates to open up into the birth canal, basically. E is the vagina or the vaginal canal, I think, is what it's called. And that's what stimulates penis to cause ejaculation and also provides a general birth canal to let the baby through. And then F is the vulva, which protects all the internal parts of the female reproductive system. Okay, how much did we do out of 6? How are we doing? Five out of 6. What did people get wrong? Is it all F? Yeah, I feel like it's all F. Yeah, which is fair. Six out of 6, but I didn't get endometrium. It's okay. It's not that good of a labeling, if you will, but it is what it is. But yeah, that's the female reproductive system. Any questions regarding the female reproductive system? Endometrium is essentially the uterus lining, yes. The line was not a part of yeah, I know it's not a very good diagram over here, but it's the best one I had at the time. Endometrium is the monthly cause of pain and screaming. Yes. Role of endometrium to provide a cushion, basically, or a protective layer for the baby to exist. It basically is thick enough to prevent like any impact from hitting the baby. I am waiting. If there's questions, I am waiting. The baby does grow in the uterus. Where did you think the baby grew? Should I be worried now? Yes, there are other forms of pregnancy that are problematic, but we don't need to know it for IB purposes. Yes, eggs do get fertilized in the oviduct. No, you can yap. No one minds. I'm just letting them know that you don't need to know it for IB. If you're curious, you can still know. But how can the body suck it sometimes at its one singular job? We don't know. Our IB just hates. It just hates us. Lipid. What does the fimbriae do? Fimbriae. There you go. It's basically what grasps the ovum or the egg instead of, because it's the tube is not connected to the ovary in the sense that it's like, it's not just gonna automatically get the egg to travel through the fallopian tube. It's what grasps the thing. It's zygote to embryo after implantation. I mean, I think the embryo is what implants. I don't think it's after implantation. The zygote is what is created in the fallopian tube, and then that divides to form an embryo, which then implants, and then it forms the blastocyst, and then it's just all the development of the baby. Okay, so the next is the male reproductive system. It's the same thing, A to E. No, sorry, A to G. When is the session going to be uploaded? I don't know, actually. It is being recorded, but I don't know what for, because it's gonna, like, the exam is like tomorrow, so. Is the ovary connected to the oviduct? Technically, no. Because the oviduct has fimbriae, which grasp the egg, so it's not actually physically connected. It's very, very close together, I think, is the logic. I was literally crying trying to understand oogenesis or oogenesis, however you pronounce it. And then I was like, why can't my body just understand myself? What is this? Like, why can't my brain understand my body? There's G. lipid. There's G. There you go. There you go. Dear God, what is your answer for B? Oh, like, what? Kirby, you're right. I believe. What is your answer for B? I'm so confused. But okay. Can you stop answering the questions without spoiling them? Because you're just ruining it for everyone else. Okay. Seminal vesicles. Cool. I'm not checking if people's answers are correct. You can do that on your own. I'm just waiting until most people have answered, or like basically until it stops. The typing slows or stops. We're not doing an option D revision session anymore, I don't think. Oh dear God, don't mix up the two. They're two completely different things. That's so bad. No, I don't think they'll execute you if it's just slightly off, as long as it still makes logical sense for it to be wrong. Like, as long as you don't spell sperm as egg, I think as long as you get the right most of the right letters and like one letter is misplaced or something like that, I think they're forgiving. Epidermis is your skin. Epiglottis is the thing that stops your food from going into your what's it called? Your the respiration system. Yes, trachea. Sorry guys, I'm blanking. Okay, I'm gonna just, I think, expect that everyone has answered, so I'm just gonna go on. A is the testis or the testicle. B was the epididymis, I don't know. So the testis produces the sperm and testosterone. Epididymis is what stores the sperm for maturation until ejaculation. C is the sperm duct, which transfers the sperm duct or vas deferens, whichever one you write. I don't think they care, but if you write vas deferens, that works too. That's what transfers the sperm during ejaculation. D is the seminal vesicle, which secretes a fluid that has fructose and that has mucus, which makes basically makes semen and makes it sticky. So, and then E is the prostate gland, which has the alkaline fluid and which both helps the sperm to swim, and they neutralize the acidity of the vagina so that the sperms can live on. F is the urethra, which transfers semen during ejaculation and urine during urination. So the urethra is connected both to the bladder and to the vas deferens. And then the last one is the penis, which has the erectile tissue, which allows the penetration into the vagina so that semen can be ejaculated as close to the cervix as possible. I did say fructose, yes. Did I already cover menstrual cycle? No, that's next. Is it Ray? I don't know. Okay. Are we good to go? How many did we get right? Did anyone get something wrong? I think lovely as in learning, I believe. I don't think so. That's just what this it's just skin. It's there. Okay. Are we good? Are we good? Any questions? No? No? This is a whole other conversation now, so I'm just gonna move on. Okay, so in relation to the male and female reproductive systems, you need to know about some steroid hormones. So, first is testosterone, which is produced by developing testes in the fetus. And that's how the prenatal development of male genitalia, including the penis, sperm duct, and prostate gland, occurs. In puberty, however, testosterone production will increase, stimulating the development of male secondary sexual characteristics, including the growth of the testes, the penis, and the pubic hair. Testosterone will also stimulate sperm production from puberty onwards. Estrogen is what is also produced by fetus, but in females. So it causes the prenatal development of female reproductive organs if testosterone is not present. These organs include the oviduct, uterus, and the vagina. The raised levels of estrogen during puberty will also cause development of female secondary sexual characteristics, including growth of breasts and pubic hair. And of course, estrogen also plays a crucial part in the entire menstrual cycle. Progesterone prepares the uterus during the menstrual cycle for the implantation of an embryo. It basically allows for the thickening of the endometrium, and it also has important roles in supporting a pregnancy. Okay, so now this is the lovely world of the entire menstrual cycle. It goes from day 0 up to day 28, so it's a 28-day cycle. Which involves fluctuations in FSH, LH, estrogen, and progesterone. Now, FSH is follicle stimulating hormone. It basically triggers the follicles within the ovary to develop and mature into the eggs. LH is the luteinizing hormone, which allows the egg to be released from the follicle. Estrogen and progesterone we of course already talked about. So the entire process of the menstrual cycle begins at day 0, which is the first day of menstruation. From day 1 to day 5 is considered the menstrual period. So if you look at the uterine cycle, and this is the thickness of the endometrium. So during menstruation, from day 1 to day 5 is when the decline and the breakdown of endometrium occurs. And then from day 5 onwards, it will grow because of changes in the levels of estrogen and progesterone. So to begin the menstrual cycle, FSH level, sorry, I forgot to mention, FSH and LH are both hormones that are produced in your pituitary gland, but they act on your reproductive organs. So in the beginning, FSH levels will see a slight rise, and then that rise will cause the follicle, which is this, to develop the egg cell into this, basically this, and then develop the entirety of the egg cell. And this development also occurs at the same time as the increase in FSH will trigger an increase in estrogen. So as you can see, FSH rises here, estrogen starts to increase. As more estrogen is produced, it further stimulates the follicle, further sends back the message to increase FSH, which then further increases estrogen. So it basically works as a positive feedback loop, where FSH triggers estrogen, estrogen triggers FSH, and then it's just back and forth. After estrogen reaches the peak that it's at, it basically stops the FSH secretion and triggers the pituitary gland to release LH, or the luteinizing hormone. So at this point, this is when FSH production sees the lowest that it's been. It stops FSH production, and then is basically where the LH will rise to a sudden peak, as you can see here. At this point, where it reaches a sudden peak due to the stimulation by estrogen, at this peak is ovulation. So it usually occurs at either the 14th or the 15th day. Now this day basically means that when LH reaches its peak, that's when the egg leaves the follicle, and the entire thing that happens is that the LH stimulates the completion of meiosis in the egg. Now, we don't need to know about the meiosis, except if you're HL. If you're SL, you just need to know that the egg goes through meiosis, and then that meiosis is completed is forced to be completed by this peak of LH, and then it also causes the partial digestion of the wall. So it'll digest this part of the wall and allow the egg cell to burst through. LH will also promote the development of the wall of the follicle. So obviously the egg has left, but this wall will basically be what turns into the corpus luteum, and that happens because of the LH. The LH triggers it to be converted into the corpus luteum. And then so once the corpus luteum has been reached, basically I think I forgot about something. Did I forget about something? No? Are we good? Yeah, no, okay. So progesterone will see a rise after, so this dotted line in the middle is ovulation. So progesterone will see a rise after ovulation has taken place, and this is because of this is so that it can promote the growing of the thickness of the endometrium. So as you can see, as progesterone levels here rise, the endometrium thickness will rise along with it. And then the LH and the FSH will stabilize because there's no more need for LH and FSH to take place, and the rise in progesterone will basically inhibit either of these from being secreted anymore. And then progesterone and estrogen levels rise from the corpus luteum, and rising of estrogen and progesterone basically inhibits FSH and LH, which is again another negative feedback loop. And then this basically means that there's gonna be a overall increase in the endometrium layer, and then it's basically preparing for the fertilized egg to implant. However, when it doesn't happen after day 28, if there's been no implantation, then the progesterone levels start declining, and the FSH levels see another increase, because this is the point at which the next basically it'll go back to day 0 and the next menstruation will happen, and then and then it'll just be a repeat of the 28-day cycle. That was a whole bunch of just me speaking. So let's look at if there's any questions. It starts with FSH production. Yes. Could they ask us to draw it? I don't think so. Oviduct is the fallopian tube, or oviduct is basically what connects the ovary to the uterus. Placenta and mother is unit 11. I will go through that, but it's just not right now. High levels of estrogen inhibit FSH secretion through a negative feedback loop. That is what happens. So basically, here at high levels of estrogen, because estrogen is at it reaches such a high level, it basically inhibits the FSH production in the pituitary gland, so it sees a fall, which is a negative feedback loop, because obviously as this increases, this is decreasing, so it's a negative feedback loop, unless unless there's a specific question. I'm just trying to go down. What was the best explanation ever? Oh my god, there's so many questions. I've been lost. Okay. There is both positive and negative feedback loops at this stage, right? So I'll explain the entire process in terms of positive and negative feedback loops after I look at some more questions, if there's any. Okay. What's the first drop in estrogen about? Are you talking about this drop? There's only one drop in estrogen, so I don't know what you're talking about in terms of first drop. How does the same hormone sometimes inhibit and sometimes stimulate FSH? It's I think at this point you just need to memorize it. I don't know if there's a specific. It just reaches a certain peak at which it starts inhibiting FSH, but it just doesn't. It's hard for me to explain to at this point. Oh, okay, yeah. So basically, the estrogen will start declining if no embryo has been implanted, because the corpus luteum, which is what secretes progesterone and estrogen in the first place, will eventually disintegrate, and then because the embryo is what usually will then take over supplying estrogen and progesterone. So if it doesn't implant, then it'll just see a fall because there's nothing secreting it anymore. The drop in day 13. Day 13. This drop is because why does estrogen drop at this point? Hold on. Actually, that's when basically estrogen, once it reaches a peak, will then force LH to reach a peak, which I think stops more estrogen from being produced, I believe. Again, No, it's the drop on day 13 has nothing to do with corpus luteum because the corpus luteum never uh, does not occur until after the egg has left. Okay, so if I go through the entire thing based on positive and negative feedback loops, um, in I'll insert another picture here because there's a better picture that has all the plus and minus signs on it, which I guess is a good way to explain. Hold on. Let me just add another one. Okay. So here this is where FSH first rises. This is where follicle will start to develop. And then as it rises, it also triggers estrogen to start rising, which is why it's a positive feedback loop, because the more FSH rises, the more estrogen rises, but then the more estrogen rises is further helps FSH to rise. However, after it reaches a certain level of estrogen, it becomes a negative feedback loop because then it inhibits the FSH from being secreted. So it turns into a negative feedback loop. That's because the estrogen basically reaches its peak. That's where it's negative. And then again, when after ovulation, this is where progesterone takes a rise. And then, this doesn't have the dates on it, which is my bad. I'll just add the dates at the bottom just so it's easier to understand, because I realize none of it makes sense if there's no dates. Hold on. Okay. Oh dear God. Okay. Here's to hoping it aligns to the best of my ability. Dear God. Anyway. Okay. So again, as I was explaining, at this point is where ovulation occurs. This line basically is where ovulation occurs. So at this peak is when LH is secreted, and then it sees another fall because there's no need to secrete any more LH. And then as after ovulation, the progesterone will see an increase, and then the more progesterone there is and the more estrogen there is, they will have a negative feedback loop to FSH and LH, which will then always be at a low point, and they won't increase until after the end of the 28 days, where menstruation will begin again, and then FSH will see another rise. It'll just be a repeat of the same process again. So the negative feedback loops happen at two places, where estrogen will limit FSH, and where progesterone and estrogen will both limit FSH and LH together. And then the positive feedback loop is when FSH increase will increase estrogen, and vice versa. Okay. So what did I miss? Questions. Yeah, the reason why estrogen inhibits the FSH according to lipid has not been discovered, which means we just need to know that it happens, but why it happens, we don't know. The all the corona radiata and stuff is all unit 11.4. 4. Yeah. So it's HL. If you're not HL, don't worry about it. If you're HL, then you should worry about it. Okay, do we kind of understand menstruation? Because it's the menstrual cycle, because it's very long and it's very confusing. Again, if there's any questions, I will be willing to answer them as like literally right now. So let me know. But while we're at it, I'm just gonna do this because it makes me happy. Okay. Cool. Okay, yeah. Questions? Concerns? Issues? Problems? FSH promotes estrogen, which in turn... Okay, so basically at certain points estrogen will promote FSH, but then once it reaches its peak, it will then inhibit FSH. But yes, estrogen promotes LH also. And it surges at ovulation. What kind of questions can they ask us about it? So it can be anything realistically. I mean, they can ask us anything that's even... They could ask us about everything that... The entire process, basically. So explaining the menstrual cycle as a whole. 4 important phases of the menstrual cycle. Yeah, go ahead. Answer that question. What's a follicle? So a follicle... Let me just... There was a no, because Lipid sent it in chat. So a follicle is basically the thing in your ovary that has the ability to generate egg cells. Yes, what that is. That is the follicle. Menstruation. Yes. Okay, so this is the last bit, and then there's gonna be like a break for like yes, I did that on purpose though. Yeah, so this is the last bit, and then we'll break down. We'll do a break, and then yeah. Okay, so in vitro fertilization, there's 4 steps to in vitro fertilization: downregulation, artificial dose of hormone, egg retrieval, and establishing a pregnancy. The fact that I didn't underline this is irking me, so I'm gonna do that really quickly. Sorry. So the first is downregulation. This occurs right before, like, when you've decided to go through in vitro fertilization. This is the first step, where a medicine is taken by the woman to stop FSH and LH secretion, which then therefore stops estrogen and progesterone secretion and suspends the normal menstrual cycle. So there's no follicle stimulation or anything like that. It just suspends the menstrual cycle, which allows the doctors to control when it occurs. And then the second step is artificial doses of hormones, where FSH and LH injections are given to the female for 10 days, and they're given intramuscularly. And I've just repeated myself here. Sorry. Are given for 10 days to stimulate basically the entire process of menstrual cycle, but without the entire process. It's just FSH and LH, which will then therefore produce estrogen and progesterone. But FSH and LH FSH injections will have much higher concentrations than normal, which will then cause super ovulation, which means that multiple follicles will be stimulated at the same time rather than the one. So usually it's about 12 to 20 follicles. 12 is the most common one, and then it can go anywhere up until 20 follicles at one during one cycle of in vitro fertilization. And then the next step is egg retrieval and fertilization. So egg retrieval is done when the follicles reach 18 millimeters, and then HCG is given to stimulate the maturation of the egg. A micropipette mounted on an ultrasound scanner is passed through the uterus wall to wash the eggs out of the follicles and basically be retrieved. And then each of those eggs will be mixed with tens of thousands of sperm. I believe the book says anywhere from 50,000 to 100,000 sperm cells in sterile conditions, and then incubated at 37 degrees C until the next day in hopes of it being fertilized. And then after fertilization, any fertilized embryo, and it's usually multiple embryos, it can be one, two, but usually they do multiple. Multiple embryos are placed in the uterus when they are about 48 hours old, and then you basically hope for the best and hope that it implants, and then after it implants, it'll continue to grow as a normal pregnancy. But oftentimes when establishing a pregnancy, since females that go through in vitro fertilization won't go through a normal menstrual cycle beforehand, pills of progesterone are usually given as supplements to make sure that the endometrium lining is good enough. Yeah, so we're done with basically all of 6.6. What is let's see if there's any questions. Do we need to know the specifics of how an egg is removed? Yes and no. You basically egg removed in terms of what? Like in terms of leaving the body, or in terms of... Oh no, you don't need to know all the specifics. You just need to know that it's usually done by washing it out of the follicles. Surrogate is the term for the woman receiving in vitro. Yes, could be. Usually, I think that is the term. Okay. So if there's... I'm going to wait for 2 minutes. If there's no questions, then there's going to be like a 10-minute break just so I can go get water and get a snack. And then everyone can also do that. And then we'll start unit 11, I believe, after the fact. But that's all of 6.6.